We'll get started here. We'll start right off talking about Boeing Starliner. We've put that off for a while. They've had their problems over the years, everything from corroded valves to software glitches that led to clock errors so that they shut off the engines prematurely, to having flammable tape. They've had a whole series of problems. You know, actually, they had their act together. They were ready, and it turned out they had other problems this time. We're getting pretty close to actually having a Boeing Starliner, we think. Well, first of all, what is it? It is designed to carry crew to the International Space Station. That's its purpose. This particular test that we actually should have just had, but they had to postpone, would have sent 2 astronauts up. They normally would take a total of 4, but this is the first flight, so they're just having 2. It was scheduled for May 6th, then it got postponed. Now the earliest launch will be May 17th, so it may still be pretty close. There was a valve problem, and it was on the Centaur rocket on the upper stage. It was not on the Boeing craft itself. It's not directly Boeing. Now, of course, ultimately, Boeing and Lockheed is a joint venture, which is United Launch Alliance, that builds these rockets. So Boeing's still involved, but at least it wasn't directly Boeing. So the history. The idea was actually they could transport up to 7 people. The NASA plan is 4 people plus cargo. I mean, the same is actually true for the SpaceX equivalent here. It actually started in 2010. People think about 2014 when NASA put out a big contract, but the work really started in 2010. They put up some of their own money, and NASA put up $570 million. So it was developed partially with their own funds, but 2014 was the big funding for this thing that got it going. It's called the Commercial Crew Program, where NASA was essentially buying a service. This is part of the shift that NASA has been making from buying stuff and running it to buying services, in this case, a transportation system to deliver the astronauts. They did this under a fixed price, and actually they've lost about $1.5 billion because of the fact they're so late. There's a minimum of 2 that they're committed to with options on another 4 deliveries of astronauts to the station. So they're way behind. The competition here, of course, is SpaceX with the Crew Dragon. They also had done some work prior to the 2014 grants. They were only given $2.6 billion, so they got less money, but they finished it 4 years earlier at least. They actually put a crew up in 2020. They've had, maybe 13 launches or something like that, and taken quite a few up to the space station, plus 1 even not related to the space station.
A question came up on the reusability of the Starliner and the Crew Dragon.
They claim 10, and SpaceX is 15. They both claim reusability quite a bit. There is, in reality, somewhat of a difference in that in the architecture of the Starliner, there's a lot of stuff in what's called the service module. And they call it a trunk in the case of SpaceX because it's pretty much just a cylinder of aluminum. It does have some radiators, and it does have solar cells for providing power, but it doesn't have engines. The engines are all up in the main capsule. Whereas here, there's a lot of engines back in the back, and there's apparently a lot more stuff. And the service modules, in either case, are thrown away. I mean, they're just burned up in the atmosphere. Now, the turnaround time is said to be about 6 months, so it's not like you can just refly the thing immediately. But they don't really need to because they were only contracted for 1 launch a year, so that fit the original design specification. So it's kind of been SpaceX versus Boeing, and so far SpaceX has been winning. But they were hoping to start to address that with this launch. So a little bit about the designs. The very top part of that is the crew capsule, and that is the reusable part. I made a note, it's kind of a minor thing, but there's no fairing. Normally, if you're launching cargo, you protect it with a nose cone kind of a thing. Those pop off after launch. You can't do that when humans are involved because if there's some kind of a problem during the launch, they have to be able to fire rockets immediately to get the thing away. You'll notice the SpaceX version does that too. Okay, the next section down is that service module that I was talking about. And you can sort of see there's a break and there's something just below that. That's basically just a skirt, and that's really just for aerodynamics that you get so much turbulence there that they want to actually direct that down so more of it actually hits the first stage rather than the second stage. And that's just is an aerodynamic thing. Now, that top stage then, the Centaur 3, that's different than what's coming up on the Vulcan Centaur now, which is Centaur 5. It's somewhat different. But one thing that's kind of weird about this is a dual engine one. They have never done a dual engine one since 2004. They say that they want 2 engines because they want more power. They want a flatter trajectory during the launch so that there's not such high G-forces on the astronauts. The highlighting is that it is very different. In fact, this is the first time an RL-10 engine, which is the engine of this thing, has actually carried any human to space. So it's kind of interesting. But anyway, this whole thing is the forerunner of the Centaur 5 that's in the new Vulcan rocket from ULA. And those do have 2 engines. Anyway, lower stage, Atlas V. Both of them use liquid hydrogen and liquid oxygen as propellant. Now, they could use something other than the Atlas V, but other than the Falcon 9, they're all ULA rockets that have been discontinued. Like the Delta IV Heavy, they could use that, but there are no more of those. There's still some Atlas Vs that are coming, but they're based on the Russian engine, and there's a finite supply of those. And when those run out, that's the end of Atlas. Another interesting part about the Starliner design is it lands on the ground, airbags, pretty much like fancier versions of what you have in your car. And there's a picture. This was one of the earlier tests, 2019. They dropped it down White Sands, New Mexico, and those are presumably the parachutes. They're kind of off to the left. Anyway, they land with airbags. And they could do a sea landing with that as well. But they were trying to avoid all the extra commotion associated with sea landings. So what went wrong? Basically, a pressure release valve failed on the upper stage rocket. You've all got them in your house. If you have a water heater, hot water, you're heating up hot water, you have a pressure relief valve to keep the thing from blowing up. It's a safety device, basically. I got the picture of one of these valves over there. Imagine your hot water tank or your rocket is underneath you there. If the pressure gets high enough, it just basically pushes up that assembly that's held down by a spring, and then it goes shooting out. It's pretty much as simple as that. So when the pressure is high, it opens up, a bunch of material flows out, and as a result, the pressure drops and it closes. Now, what's happened here, though, is they're getting what's called chattering, where it's opening and closing very, very rapidly. They're not supposed to work that way. That's not the normal design. Sometimes that indicates a design problem. I mean, you can imagine if the thing were really made way too big, what will happen is the second you open it a little bit, a huge amount of material leaves, and then it would slam shut, and then it would build back up, and you'd open and let out a huge amount. So that's one way. And you have some different sort of problems that happen if the valve is too small. We don't actually know what the arrangement of this thing is inside the rocket. I mean, for instance, if there's a pipe leading to it, actually that could be a problem because you get too much pressure drop. You try to force a lot of material through a pipe that's too narrow. It's just like sizing the thing too small. And what will happen is the pressure decreases so much that then the thing slams shut because of that. Basically, there could be a design problem. You wouldn't think that'd be it because this is pretty mature technology unless they changed something on the Centaur with the two engines. So it was not completely clear why. This thing was chattering really fast. I mean, they're talking about like 40 cycles a second, 40 hertz. They heard it. The reason they knew they had it wasn't from instrumentation. They saw that later when they started looking at some detailed data. But basically, the ground crew heard it. Why did they have these kind of problems? It could be a design problem, but probably not because they've done this before. It's probably just a defect. It is funny, though, because certainly Boeing has had their problem with valves over the years. It's like whoever they buy valves from, they ought to buy them from different people. It's a tough service, though. I mean, we're talking about liquid oxygen. It's cold. So metal's brittle, and that's actually a problem with something like this. If you get shattering, the thing's banging away 40 times a second. That's not really good for most metal when it's brittle and it's, 100 and whatever degrees below zero. Their particular limit on this valve was 200,000 cycles. And you think, well, wow, that sounds like a really big number. But if you think about that, if it's really opening and closing 40 times a second, that's only a couple hours. It doesn't really take that long to hit it. Now, what they said was, if it doesn't open all the way, it's not quite as bad. It's the worst case if it opens all the way and then slams back. If it's just a little bit, maybe not. One way or another, they've got to figure out why they're doing that. They apparently have had this problem before, at least twice. And once very, very similar, maybe 10 years ago, was on a cargo. And what they said was, if you have humans, you're not really allowed to change the state of the system because it's just too risky. The problem is, they have a solenoid, which is an electrical plunger, essentially, that can force it open or force it closed. And on the cargo versions, they just forced it open, forced it closed, and everything kind of settled down, and they went on their way. You don't want to do that when you have people. The problem is, imagine if you force it closed, well, what if the pressure really is building fast, the whole thing blows up, and you care a lot more if there's people there. On the other hand, if it's open, you're putting out a lot of stuff in the atmosphere. In this case, it's only oxygen, but still, you might get an explosive mixture. You're much more likely to renew the rocket. So they say, well, if you have people involved, we don't do that. So these people are saying, gosh, if only it were just cargo, we would have just ignored it and gone ahead. But they couldn't do that. At least that was their own official policy.
Also, if too much oxygen leaked out, it might not even be possible to reach orbit.
All those things anyway, saying you might take risks if it's only cargo, but you're not going to do that with people. So anyway, they're going to have to replace it. Now to do that, they got to go back to their vehicle integration building, their hangar. And they said they don't have to unstack the thing, but they have to be able to support it while they're taking it apart so it doesn't collapse. Once you've gone to all the trouble of taking it back, you are going to replace it. I mean, then they can look at the valve, and afterwards you can tell. They don't have direct data on this. What they do have is the accelerometers in nearby places, like the engines, actually could pick it up. So they have some data on that, but they actually had that the same day. So that's the story on that. That's what went wrong. Okay, lunar missions. I've got a whole bunch of those. Most of this is updates. The big one is the Chinese launched their big lunar mission. Now, this is a robot to land on the far side of the moon. Now, they've done this, is actually that exact same lander that I'm showing in the picture there was Chang'e 5. That one worked. This is essentially supposed to be a duplicate of that. It was sort of the backup if the other one failed, but this one succeeded. So they decided this one they're sending to the far side instead of to the near side. Now, they had also visited the far side before, but they never did sample return. And this one's going to do kind of a combination of everything. Far side, sample return, which is something that actually we've never done except with people years and years ago. It takes a lot more sophisticated automation to actually make all this work. So far side, near the South Pole. Now, it turned out there was a surprise. They saw in some recent pictures that, oh, there's probably a rover included with this as well. They had that in some of their other landings. Actually, the last far side landing included a rover, but it didn't include a sample return. So this is just putting all of it together. And they also had a lot of science payloads, looking at a variety of things from France, Italy, Sweden, and Pakistan. The Chinese are definitely trying to get more international cooperation there. And it will return 2 kilograms of samples, which is exactly the same size as their last sample return mission from the near side. They'll take samples, some from the surface and some down as far as 2 meters, drilling down. And it'll be a 53-day mission. It's relatively short. In fact, they'll take the samples all almost as soon as they land to get that out of the way. So the timeline here is they just launched it May 3rd. It achieved lunar orbit on May 7th. Now, the thing is, where they're planning on landing, it's not going to be lunar sunrise until May 28th. Remember, you have a 28-day cycle, day-night. 14 Earth days of daytime, 14 Earth days of nighttime. So actually, they're just using that time to get their orbit exactly the way they want it. They will finally land then sometime in early June, take the samples within 48 hours. They take off. They have an ascender. The top part of the lander you're seeing there, that thing there, that's the ascender. That's what goes back up. So it goes back up and meets the orbiter, which the whole system had detached from earlier, and dock with it. It'd take about 2 days to get to that. Then they'd get rid of this ascender. They don't want to take that all the way back to Earth. Then we return to Earth. Now that thing then drops off a separate little capsule containing the samples there. They release that somewhere on land. They still have fuel left on that orbiter, so they'll send it somewhere else. They did that last time, too. They've typically sent these things to various other places, so try to get as much use as they can out of their craft. So it's actually relatively sophisticated. In a lot of ways, it's done kind of like the Apollo missions were, where you have the same kind of complexity, where you have an orbiter and something detaches to go down to the surface, and then something detaches from that to go back up. Something is sent back to Earth, and it detaches and goes down to the ground on Earth. Same basic idea. But they made it work all automated. Okay, some other ones. We've talked about the Japanese Slim lander before, so I'm not going to rehash much of it, just that it landed upside down. The solar cells were facing west, so they couldn't get any sunlight in the morning. They only had a little bit of time in the afternoon. And it survived 2 nights. Well, it just survived another lunar night. They didn't expect that. So actually now people are thinking, well, there must be some lessons here. Why the heck is this thing surviving? Most of the electronics really die, in particular batteries and that kind of thing. They just die going through all that cold for such long periods of time. Okay, another one. This is a much bigger project, Orion spacecraft. Now, this is what's going up with the Artemis program. When we land astronauts on the moon, Artemis is a program for doing that. And this is the spacecraft that will carry them. In particular, it takes them on the launch from Earth up to lunar orbit, and then at that point it meets up with the human landing system, which happens to be either SpaceX or Blue Origin. That goes down to the moon. They come back up, transfer back to this, and this comes back to Earth. So it's pretty crucial to the current plans that they have for Artemis. And just to set the tone on what the parts are, the craft itself, on the far right-hand side there, it has the basic capsule and it has a service module, pretty much like Starliner, same basic kind of a design. And that's the kind of thing that will get discarded, only the capsule that actually come back to Earth. In terms of how it's packaged up inside the rocket it's launching on, you see that more on the left-hand side. The very front of the rocket, you're going to have the launch abort system, which is a separate system with engines so that there's some kind of a problem on launch. They can fire those engines and bring everybody back safely. Crew modules behind it with the service module, and then there's just various adapters and stuff to attach it to the rocket they're launching on. Those are the basic parts, the crew module, the service module, In the early stages, you have a launch abort system and various protective panels.
As an aside, modern crew capsules have done away with this type of launch abort system called a tower, which carries engines above the capsule. Instead, they integrate the engines into the crew capsule itself or its service module. So that way there's no tower to dispose of and possibly interfere with successful launches. Integrating the engines into the crew capsule is the best option from a reusability standpoint and hence cost, because the engines are recovered instead of discarded. Both SpaceX's Crew Dragon and the Blue Origin New Shepard do this. The Boeing Starliner also eliminates the tower, but it puts those engines in a service module, which is still discarded, so it doesn't really maximize reusability. Anyway, back to the Orion audit issues.
There was an audit that just came out, and this is why we're talking about it now, on May 1st, and they've detailed the safety problems, and most of these were actually known. The real question was, how serious were they? And what they're kind of highlighting is that maybe they're more serious than people had thought. In particular, there was extensive damage to the heat shield, and this really matters. We've been doing a lot of returns from low Earth orbit. Every time we go up to the space station, we come back down, and you're going like 17,500 miles an hour, that kind of a speed. When you're coming back from the moon, they're coming back at more like 25,000 miles an hour. The energy that you have to dissipate goes up as the square of the speed. So that says that you've got a lot more energy you've got to dissipate with the heat shield. And they had a lot of damage. So I'll show you the picture later. About 100 places where they said this is way too bad. There were some problems with some of the bolts too. There's bolts that were separating the crew module from the surface module. Those have to blow apart right before you come back to land on Earth. And they melted so badly to the point where they got worried that you could have hot gases entering and again destroying the capsule. And they had some other stuff, power distribution issues. Those things weren't as much of a big deal. The biggest single deal is really the heat shield. And the audit did note that NASA was aware of these problems and working on them. What they really were just doing was cataloging that, hey guys, you got a problem. It may affect the schedule. It took this kind of an audit to bring that up. It's like it was sort of being covered up. Nobody wanted to talk about it. And this is why. You look at these pictures. These are both just pictures of the heat shield and maybe a close-up. There's big chunks there. This does not look pretty. Now, that said, actually, temperatures were still okay. But, you have to worry that it just performed slightly worse. Any one of those holes could have been enough to start eating away and destroy the integrity of the whole thing. So that was a serious concern. That picture pretty much says it all. Okay, so anyway, that's the bad news there. The bolts, they're showing you where they are. The heat shield will go over this diagram on the left here, and you can see what it looked like originally is where the little red circle is. And then this is what it looked like after, where the heat and wind had eroded it away. And this is another place where if it went much farther, you risk the potential of serious damage. Okay, another one. NASA is having a series of problems, partially just because of funding and partially just because of what they had planned. We've had a big project kind of in the background here, the Mars sample return. We've had the Perseverance rover up on Mars collecting samples and dropping little cylinders off with sample material. But we never really fully worked out how we're going to get them back to Earth to actually analyze them. The project was officially called Mars Sample Return, and there have been several iterations of it. Actually, just earlier in the year, they simplified it quite a bit. They said, well, instead of having an extra rover to go out and find the samples, they'll just use Perseverance-style helicopter, a little bigger version of that helicopter. And they were trying to simplify it, but they're realizing now that still is not simplified enough. The costs keep going up. And right now, it's looking like it'll be $11 billion, of which maybe a couple billion's already been spent. And the other thing is that you wouldn't actually get the samples back until 2040. So none of this is making anybody very happy. They're saying it costs a lot and it's taking forever. Maybe there's something wrong here and we ought to rethink this. So they're not really saying they're going to abandon the whole concept of bringing the samples back. What they're saying is, somebody help us. We got to figure out how to do this cheaper. They're really hoping somebody like SpaceX will come up with some way to bring it back. Robert Zubrin of the Mars Society has suggested some other ways of doing this. There's various ways that it might be done. Big thing is just cutting out pieces of the complexity of the thing. Originally, you're going to have a lander with a rover to go out to the other rover, the Perseverance. And then, okay, they cut out that by saying, well, we'll just bring Perseverance back. That cuts out one rover. But you still have this missile that was going to go off and take it up to an orbit above Mars. And then from there, it'll transfer to something else, and they'll bring it back to Earth and transfer it to something else. It just got so complicated. Zubrin claims that basically it was designed in a way such that everybody who is involved in any projects associated with Mars has a little piece of it. So everybody gets their piece, and maybe you don't really need all those pieces, kind of what he's saying. So anyway, hopefully somebody will come up with much, much more simple ways of doing it. On the other hand, a mission that does have a full go now, is the helicopter on Titan, which is a moon of Saturn. We talked about this a little bit a few months ago, but that was actually approved, and that's about 3.3 billion. That's an octocopter. And it turns out, Titan is a great place to have a helicopter because the atmosphere is really dense. It's 1.5 times that of Earth. The gravity is low. It's like lunar. So it's exactly the opposite of Mars, which had almost no atmosphere to speak of. Flying is probably the easiest way to get around there. So anyway, that one's still a go.
This project led to a discussion about conditions on Titan.
Solar cells aren't terribly effective. You notice there's no solar panels on this thing. Well, I'm just talking about being that far from the sun, you just don't get anywhere near as much sunlight.
And there's all those hydrocarbons.
Yeah, they have methane lakes. So that's the catch. Of course, it's very cold. They have rivers and lakes there, but they're methane. Definitely, there's plenty of methane. There's plenty of hydrocarbons on Titan.
How cold is it?
Well, methane at Earth atmospheric pressure is like minus 260
Fahrenheit.
Now, this is a little higher pressure. It'll be 50% higher pressure. So it would be warmer than that.
Pretty darn cold.
Still PDC, yeah. We'll call it pretty darn cold, yeah. I mean, you will definitely be wearing gloves. You won't go out without your hood and your gloves.
This abundance of hydrocarbons led to discussion on our future economy in space.
The future of space economy, as we go into space, fundamentally, you just have certain things that are concentrated very differently in different places. So here, for instance, this could be a source of hydrocarbons. You've got plenty of them. Other places, you may be able to get oxygen out of the regolith.
Or perhaps from electrolyzing water ice from Titan. So, once we find a source of oxygen for Titan, Doug pointed out that we could build jet engines for Titan that pull in methane from the atmosphere with oxygen fed from a tank.
Okay, now that we've talked about how there's not enough sun out there, we'll talk about solar sails. Of course, what else would follow with that? There's a new solar sail mission in town. So it was just launched. And so we'll back up a little bit and talk about it. First of all, what is a solar sail? It is literally sailing through space based on the pressure that you get from the sun. Photons have
momentum,
and they bounce into a surface like that reflector there, and they bounce back off. The idea is it comes in, you have the angle of incidence equals the angle of reflection and all that. So, it bounces off at an angle. So if the plate's at an angle, you can direct the thing different than just the direction the sunlight's coming from. Analogous to how you can tack with wind on the Earth with a sailboat. So it's sort of analogous, not exactly the same mechanism. But anyway, the idea is by angling the thing compared to the direction the sunlight's coming from, you can orient yourself and you can change your direction. And this goes back to science fiction, but it is actually true. People have proposed that also you could power a solar sail with lasers from a distance. Then that way you get a lot more concentrated light. It'll spread out a little bit, even at a long distance, or maybe quite a bit, but that's okay. You just make the reflector as big as you need to be able to catch that. So that's the basic idea. There have been built already. Actually, the most successful one was the very first one that was done outside of Earth. The Japanese did one back in 2010, and that's actually, it's a drawing of it there. And what's common to most of the solar sail projects is the main spacecraft body is something fairly small in the center of it. And then typically you have booms, just like you have booms on a sailboat. They're just basically masts on which you string up this big sail, and there's a sail there. Those two key parts are in all these things. Why do you want solar sails? Well, the big thing is the solar sail mechanism uses no propellant. Now, to get the thing going the right way or to make really big course changes, you may want to have some propellant. And they've gone either way on this.
The other
thing is, there's very few moving parts to this thing to fail.
Once the sail is opened up.
In theory, you can get to very high speed with this. It takes a long time to do it. So you're not going to send people, on solar sails. It seems like that's pretty unlikely. But you might send cargo. What you're really going to use it for is mostly missions of exploration. You might want to survey asteroids. And actually, one of the ones that failed more recently was, in fact, going to be an asteroid surveying one, which we'll talk about.
There was a question about material for the solar sail and damage from micrometeorites.
It's actually extremely thin, typically a polymer. It's like mylar. If you have like mylar balloons or something, very, very thin, and they can get punctured. And usually their design accounts for some of that. It doesn't necessarily invalidate it. Unlike a balloon, it's not just going to deflate or something. You just have little holes that won't be quite as effective, because you're still going to get light reflecting off the rest of it. So even if it gets some little holes in it, it's not the end. Now, if it gets all scoured by a lot of micrometeorites, maybe the reflection won't be so good. So it will affect it, but it won't necessarily destroy it. That picture, that's back in 2010. More details on this. That was 46 feet by 46 feet, gives you an idea. It's a polymer, 7.5 micrometers thick, so very, very thin. If you compare that to your garbage bags, those are measured in millimeters. You're talking about units that are 1/1000th the size of that. That gives you an idea. Because you basically want as little weight as possible, the solar pressure is not very much. So you want everything to be light, and that's why they keep making them thinner and thinner. The thing weighed 310 kilograms. It was reflective. There is possibly another way of doing solar sails relying on diffraction, which is a different thing, which is interference of light waves. It's a much more complicated thing to do. It's been proposed.
And studies of it are being funded by NASA through their NIAC program. That NIAC acronym stands for NASA Innovative Advanced Concepts. Every year they do a public review of all the research they fund. Last year Doug attended in person and I attended it remotely. The studies are quite interesting. Anyway, getting back to solar cells based on diffraction.
With diffraction, you can essentially direct the reflected light almost anywhere you want. And so you have much better control over it. So there's some benefits to it. Also, a lot of it just passes through and it doesn't heat the thing up as much. A couple things about this one. They need electrical power. So they put some solar cells, kind of that band around there that's shown in this diagram. But there's something else they did that was very interesting that nobody's done since. If you want to change your direction, you got to change the angle at which the sun hits it. Well, how do you do that? You don't want to use propellant to do that. That's no good. That kind of defeats the whole idea of not needing it. So what the Japanese came up with was, what you want to look at is the difference between the center of mass and the center of the pressure exerted by the sun. If you can shift that around, you can control the direction. And what they did was, around the outside edge there, they put some LCD panels of crystals, and they just basically could cut it off so it reflected or didn't reflect. So what you do is, maybe on one half there, you would cut back on the reflections quite a bit, and that would cause the whole thing to tip. And it's kind of interesting. The amazing thing is it worked. This was on a mission where they had something else going on. They tagged along on a mission to Venus. And so the whole thing kind of started closer to Venus. But anyway, around 2013, they had increased their speed. Now, it only increased it by 890 miles an hour, which doesn't sound like a lot, but still it does show that the mechanism was working. They lost contact around 2015, and it was maybe 110 million kilometers from Earth. And somewhere in solar orbit, somewhere going away from Venus. So it's out there. It does work. That part's been proved. Now, next step, NASA did a project called the Near-Earth Asteroid Scout. They were going to go out and look at small asteroids, essentially doing surveying and scan them. Now, this looks like some kind of weird ice cream cone. It's not. Those little red rays there are supposed to indicate the scanning is going on. This is an artist's conception kind of a thing. It doesn't really look like an ice cream cone. That's an asteroid, and that's the thing going by it. The craft itself is, of course, the solar sail there, and then there's a little CubeSat down inside of it, meaning pretty small. That thing is 30 by 30 feet. It was a little bit smaller. Think of it like, like a tennis court kind of size. They used thin metal booms. They shielded them from the sun. What they concluded, and actually their biggest concern, was that when those metal booms get heated up, they warp, and that screws up the direction they're pointing. So that was the biggest concern. They essentially always hid that, made sure that the sun was on the other side. That was a big deal in their design. So the satellite in the center is a 6-unit CubeSat. Each unit is a 4-inch cube. And so it's like a shoebox size. So that thing in the center is sort of shoebox size. The whole thing weighed about 31 pounds. And notice they got the thickness of the solar sail down to 2.5 micrometers. The last one was 7 something. They're definitely going for even lighter. And what they do is they put a thin layer of aluminum on it to help the reflection. This actually included conventional control mechanisms. It had reaction wheels. These are basically spinning flywheels driven by a motor. So if you want to rotate the craft, you just either speed up the motor or slow it down, and you transfer momentum between that spinning wheel. And that's what's done actually in every satellite, typically. Then they had cold gas thrusters for major moves. If they wanted to make a big, big change, something you can't do with a solar sail because the pressure is so little. They still had some of that. But they went a little further. They have another new thing called the active mass translator, and that's in the center of it. And what they did was they went back to the Japanese idea, and they said, well, okay, shift the center of mass. We have a weight, and we're just going to move it, either to left, right, or up and down, to shift the center of mass of the whole thing. And so they made that work, or they're going to make that work. The catch is the whole thing died. It was part of the Artemis 1 mission. Remember the Artemis 1 mission? That was to send an unmanned craft around the moon. It was the first of the Artemis missions. But they had a bunch of ride shares, secondary missions. There were 10 of them. Unfortunately, that one had gotten delayed so much that most of the batteries gave out on a lot of the things that were in that. And this apparently was one of those, because this failed. It lost contact immediately after being launched. And what most people think happened was probably the battery was just dead. And that was just from sitting around too long. It was too bad. But that, these things happen. Okay, so the one that just launched, it's a new one, a little different. They made a little different polymer. We're down to 2 micrometers now. This one has foldable metal booms also. They coat it with aluminum. It's 0.1 nanometers. And again, we're talking yet another factor of 1,000 on thickness. You're talking down to a few atoms thick probably. And the other side's coated with chrome for heat radiation. This one, the CubeSat, they call that a microwave size, 12-unit CubeSat, 9 by 9 by 13 inches. They're just doing this in low Earth orbit right now. They want to test the unfolding mechanism, because what they're trying to do is figure out how you pack something into such a small package and merely make sure you can get it undone. Not an easy thing. They're going to consider this mission a success if they just manage to get the sails extended. And that just got launched on an Electron rocket. So it's kind of funny. Their previous launch that NASA had for a solar sail was on the biggest rocket that was available at the time, which is SLS. This one is launched on probably the smallest commercial one. And it was shared with another payload as well. This whole thing is just not that big. There's a video of this just showing the sails opening here. And they don't show it going all the way because it'll suddenly flip. You'll see the, what it looks like there. So, but anyway, this is why they want to test it out. It's, a lot of things could go wrong. Things could break, get holes, whatever. It's delicate. This is what it looks like, by the way. This is that solar sail. You can see the size based on the people there. That's what it looks like when it's fully extended. Okay, a quick update. We talked about Varda Space in previous times. What they're doing is manufacturing drugs or other things up in space where microgravity was actually a benefit. You can grow crystals much better there, which was needed for this particular drug. And we talked about that they actually managed to land back on Earth successfully, but we hadn't gotten the lab results back. Well, now we finally got the lab results back saying the drug was good. This is a go. You can actually make these drugs. You want to do expensive drugs, but they'd have it. It's used in Plaxivid, which is what's used for COVID treatment, and also it's an HIV treatment. The other thing that came out of this was the FAA just recently had announced that from now on in, if you want to have a re-entry license, you got to get that before we're going to give you permission to take off. It turned out they didn't have that before. They didn't need to do that very often. It's really just been astronaut missions that come back to Earth. Almost nothing else did. Well, in our future in space, we need to be able to manufacture some things and bring them back, or sample return missions too, same kind of thing. And now they're going to take it more seriously. That was a big thing. If you look at the time scale there, they launched in June. They were done in 3 weeks, but it took them another year before they could actually land because they didn't have permission to land. Okay, so what's coming? Starship Flight Test 4 is coming up very, very soon here. We're not sure, but could still happen in May. Pretty much the same as Flight Test 3, but trying to solve the problems that were exposed. The biggest single thing was controlling both stages as they descend, after they've been used in their primary mission. They managed to get up. The problem was we want to be able to reuse everything, and they lost control. They lost control in space, which meant that the cold gas thrusters weren't working properly. They lost control in the atmosphere, which meant that the fins weren't working properly. And either they weren't working properly, the control was wrong, whatever it was, they need to fix it. So that's a big thing. The other thing is they do need to test restarting the vacuum engines up in space. They haven't actually done that yet. So that's the other big thing. Actually, if they get those two things done, they're getting close. Their best case is landing vertically on the ocean under control at predefined coordinates, because if they can do that, then they can think, well, okay, now we can talk about bringing it back and landing back at the launch site, which is what they ultimately want to end up with. So the first thing is trying to do the same thing, but doing it out to sea. They will do that at least once anyway before they try to bring it back to land. That's about it. Okay, here we ask the question, how many launches do people think we've had since the last meeting? Now, my understanding, you're always high. Ah, you really did your research, didn't you?
I did.
Well, just for the record, she did not see the slides ahead of time, but that is in fact the right answer. Yeah, okay. So you had to work. Okay, you had to work at it, but you found out the answer. And what's interesting is it's really just China and America. If you look at these flags here, that's it. There's just nobody else doing much of anything. And certainly, Europe is kind of out of the picture. Every now and then you get something from Iran or North Korea or something, but none of that really, it really comes down to it's the US and China. Maybe just a few interesting things, that we tend to forget about it, but the Chinese have a space station. They did a recent, resupply mission. That's the 13th crew replacement mission they've had. They've already had that many. They're up there, they're doing all kinds of stuff, even things that we're not doing, like they're doing more in what they call the bioregenerative stuff, growing stuff on the station. They also launched the lunar lander and sample return mission we talked about. An example of the problems the European Space Agency has, they are putting up their own new navigation satellites, their GPS equivalent. And of course, they always assumed they'd be using it on their own rockets, but their own rockets are in between. The old ones, they're not making anymore. The new ones aren't ready yet, so they're forced to go to SpaceX to do that. I guess the other thing is the Chinese are starting some of their new satellite constellations. They have a whole bunch of them coming. This one's a bunch of them in medium Earth orbit. This is kind of like the O3b constellation is now owned, I guess, by SES, where it's in medium Earth orbit, so you don't need so many satellites, but you have a little bit more time delay, for up and down. But they're launching one of those, not very big. It'll end up being like 14 or 16 something satellites, something like that. They have others that are coming along pretty soon, though, that are up in the thousands, kind of like what SpaceX has been doing. One of them, they're projecting 12,000 satellites. So there's a lot of really big satellite constellations yet to come. The last one here, the Falcon 9 that just launched recently, they launched 20 Starlink satellites instead of 23. That's because they're now adding these direct-to-cell capabilities to it. They need bigger antennas so they can communicate with your normal, ordinary cell phone. And first just for text messaging, but later it'll be for other things. They're not the only ones doing it, but it's going to be pretty hard to compete with SpaceX. They have so many things going up, and they just slapped up 13 of them. Their competition has only put up a couple test satellites. I think that's probably it.
Other space-related videos or slide presentations by me are available at the link shown here. That includes a list of videos at my YouTube channel, so you can view them or subscribe for notifications about future videos. These presentations are mostly made as part of the meetings of National Space Society's North Houston chapter, and a link to that is shown. Topics like these are presented as part of a monthly news segment, and there are also lots of other interesting speakers and open discussions. You can attend in person or online via Zoom. Come join us.